All right, so our lesson today, we're looking at solving systems of linear equations. Today we're going to focus on looking at linear equations by graphing. So basically this next few lessons, we'll be looking at linear equations. So we're still looking at lines, but we'll be looking at two lines and what it means when we see two lines intersecting together and what that means. So let's take a look at our first example here. So the Smith family and the Harper family are going to a book fair raising money for charity. Mr. Smith pays entry fees of $11 for 3 adults and 1 child, and Mrs. Harper pays entry fees of $12 for 2 adults and 3 children. So based on that information, we can come up with two equations. All right, so we're going to form these two equations. We're going to let X be the entry fee for an adult ticket, and Y is going to represent the entry fee for a child. All right, so again, the Smith family, they paid $11 for 3 adults and 1 child. So 3x plus y, or 1y, equals 11. So x again is representing adult, and y is representing the child. Then we had the Harper family. They paid $12 for 2 adults and 3 children. So 2 adults, so 2x, plus 3 children, so 3y, and it was $12. So that's how we get the two equations. The next part of this question is to draw the graphs. It does say to use without using technology. What we'll do is we'll graph them, and then we will confirm our graphs by looking at our graphs on our graphing calculator. So the first thing we need to do is take our two equations and put them into a form so that we can graph them. So we'll put them into our y equals mx plus b form. So the first equation was y equals, it was 3x plus y equals 11. So that's our first equation. 3x plus y equals 11. And we just have to put this into a form so that we can graph it. Very easy. This is already just y. We just have to subtract the 3x on both sides. So our first equation we get is y equals negative 3x plus 11. That's our first equation. All right, we have our slope and we have the y-intercept. So since we have those two pieces of information, we can easily make a graph of our the first equation. The second equation that we are given is 2x plus 3y equals 12. And I'm just going to put this equation into y equals mx plus b form as well. So I have my slope and I have my y-intercept. All right, so to do this, I'm going to subtract the 2x over. So I will have 3y equals negative 2x plus 12. All I've done is subtract this 2x over to the other side. And next I'll just have to divide by 3 on both sides. So I get y equals negative 2 over 3x, and then 12 divided by 3 is plus 4. All right, so for my second line, here is my slope, and here is my y-intercept. All right, so those are my two lines. So let's get our graphing paper here and do quick sketches of both our lines. So I'm just going to do the quick sketches right on here. So for my first line, my my y-intercept was at positive 11. So right here is my y-intercept, and my slope was negative 3. So down 3, 1, 2, 3 over 1. 3 over 1, down 3, over 1, down 3, over 1. So that's basically, I've got my points there, and then I can connect my points like that. Second line, the slope was negative 2 over 3x, and the y-intercept was at 4. So 1, 2, 3, 4. There's my y-intercept, and my slope is negative 2 over 3. So down 2 over 3. Down 2 over 3. And down 2 over 3, like so. So you can see now here the two lines where they crossed. All right, so the two lines are crossing right here. And that point is at 1, 2, 3, and 2. So that point is at 3, 2. All right, so what does that mean, that point where they are intersecting? So recall that when we first started, we said that X represented the cost of an adult ticket and Y represented the cost of a child's ticket. All right, so since that point of intersection was at 3, 2, all right, this is our point of intersection. That's where both lines are crossing. This is our X, this is our Y. So since X represented the cost of an adult ticket, our X is represented as $3 for the adult ticket. So $3 for the adult ticket, and our Y value is equal to 2, so $2 for the child's ticket. All right. So what we're doing next with these two equations is we're just going to confirm our point of intersection using our graphing calculator. So put in both of the equations into the graphing calculator. So first equation is y equals negative 3x plus 11. And our second equation was y equals negative 2 over 3x plus 4. So I've just done that here. I've put both the equations into my graphing calculator. I'm going to hit graph next. And there's the two lines. So we can see that there's an intersection point right about there. So to figure out the intersection point, you're going to hit second function trace. And you're going to scroll down to number 5. Recall, number 5 is the intersection. So scroll down to number 5, and we're going to hit enter. All right, it's going to ask you for first curve, you're going to hit enter. Second curve, make sure the cursor has gone on to the second graph, hit enter, and then it's going to say guess. You're going to hit enter, and our intersection point is at x equals to 3 and y equals 2. So that's confirmed. Exactly what we had gotten when we had done our graph manually. So intersection point is at 3, 2. So what we found in that previous example is that those two equations, 3x plus y equals 11 and 2x plus 3y equals 12, they're a system of equations, and the solution to that system of equations was at point 3, 2, where x was equal to 3 and y is equal to 2. And the reason being is that that point 3, 2 satisfied both equations in that system. All right, so when we're looking at graphs, the intersection of the two lines is the solution to that system. So let's take a look at this graph here. In this graph, we have also two lines, and they're intersecting at a point right here. So that intersection point here is going to be the solution to this system. Okay, so over to 2 and down to -1. So the solution to this graph would be x is equal to 2 and y is equal to -1. All right, so our next example we're looking at, we're given two equations, 2x plus y equals 2, x minus 3y equals 15. We have to graph these two equations without using technology. So one method, again, is put them into y equals mx plus b form. Another method you can use is find your x-intercept by making y equals 0, find your y-intercept by making x equal to 0. You'll have 2 points on the line, and 2 points is enough to then draw your line. All right, so let's do that. So our first equation is 2x plus y is equal to 2. That's our first equation. So looking at this one, it's very easy because we just have y here. So just subtract the 2x on both sides. So y is equal to -2x plus 2. So that's our first equation. This is our slope, and this is the y-intercept. The second line equation that we're given is x minus 3y is equal to 15. So you can do this, put it into y equals mx plus b form as well. You can also figure out your x and y intercepts to get 2 points on the line. All right, so if we were looking for our x-intercept, you just make y equal to 0. So I'm looking for my x-intercept. I'm going to make my y equal to 0. So because x becomes x minus 3 times 0 equals 15. So x is just equal to 15. And that point then would be 15, 0. And then if we were looking for our y-intercept, you would make your x equal to 0. So that would become 0 minus 3y equals 15. Negative 3y equals 15. Divide both sides by -3, and we get y is equal to -5. So then your second point on the line you could use would be 0, -5. All right, so that's one way. You can plot your x and y intercepts and draw the line out. Or you can just take that equation and put it into y equals mx plus b form, which I'm going to do as well. I'm just going to do this. So x minus 3y equals 15. And I'm going to solve it for y to put it into y equals mx plus b form. All right, so what I can do is I can add the 3y to both sides. So that gives me x equals 3y plus 15, and then subtract the 15 to this side. So x minus 15 equals 3y, and then divide by 3. All right, so that gives me y is equal to 1 over 3x, and then negative 15 divided by 3, which is -5. All right, so now I have my slope, and I have my y-intercept. And notice that the y-intercept is -5, which is also the y-intercept that we had found here, 0, -5. All right, so I'm just going to plot the first line. So our first line was -2x plus 2. So that means our y-intercept was at 2, and our slope was -2. So go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, so as long as you have 2 points, you can draw your line. I just went a little bit more. All right, so there's our line for that first graph. And our second graph, we have our y-intercept at -5, right there, and our slope is 1 over 3. So our rise is 1 and our run is 3. So up 1 over 3, 1, 2, 3, right there, up 1 over 3, 1, 2, 3, up 1 over 3, 1, 2, 3, and connect those together. There we go. So here we see our intersection point right here. So our intersection point is at +3, 1, 2, 3, and at -4, 1, 2, 3, 4. So 3, -4 is our intersection point. All right, so that is the solution as well. So the solution to these two equations is at 3, -4. All right, so just to verify using our graphing calculator, so we have these two equations here, y equals -2x plus 2 and y equals 1 over 3x minus 5. So those two equations, I've just put them into my graphing calculator like so, and I'm just going to hit graph, and there's my graph. So now I want to figure out where are the two lines intersecting. So they're intersecting right there, but I need to figure out exactly where they're intersecting. So second function, trace, scroll down to 5, which is intersect, hit enter. Make sure the first cursor is on your first graph, your first equation. Make sure the cursor then shows up on your second graph. And then it'll ask you to guess, press enter, and our intersection point is at 3, -4. So the exact same that we had found when we did our graph manually. So our intersection point is 3, -4. All right, so our solution, therefore, our solution to this system of two equations was 3, -4, and again, that is where the two graphs intersect. All right, so the last part of this question is to verify the solution algebraically. So verifying the solution, our solution was 3, -4. So when we verify the solution algebraically, you have to do it for both equations. So we're going to substitute 3 for x and substitute -4 for y in both equations. Left-hand side has to equal to our right-hand side. If it does, then it's verified. All right, so here we end up with 2 times 3 plus -4, or just -4, has to equal to 2. 2 times 3 is 6, -4, 2. 6 minus 4 does equal to 2. Left-hand side equals right-hand side, so it's verified for our first equation. Next, we have here x minus 3y equals 15, so same thing. Substitute 3 for x and -4 for y, and it has to equal to 15. So 3, and then -3 times -4, that's plus 12, has to equal to 15, and we get 15 on our left side, which is equal to 15 on our right side. So the solution, therefore, our solution to 3, -4, works for both lines, and we've just shown that algebraically. So the next part we're looking at is number of solutions to a system of equations. And from our previous example that we had looked at, if two lines will intersect, like in this example, you have one solution, and that's the solution where the two lines intersect. But if you have two lines that are parallel, so these two lines are showing parallel, they will never have a solution. So there will be no solution because the two lines will never intersect. They are two lines that are parallel to each other. They will never cross each other. They will just remain parallel to each other. So again, you know that they're parallel to each other because they have the exact same slope. So a slope of 2 and a slope of 2. They're parallel and they will never cross, therefore they'll never have a solution. And the last type of system you'll get is where you have two lines that become the exact same line. So it's one line and the second line is on top of it. So that is called collinear or lines that are coincident, and they have an infinite number of solutions because both lines are on top of each other. So each point on this line will be a solution to the equation. So what I'm going to do quickly is just show you how both of these equations turned out to be the exact same line. All right, so what we need to do with these two equations is this one is already in y equals mx plus b form, so this one is fine. The second equation is given in general form. So what we'll do is put this general form into the slope-intercept form, which is our y equals mx plus b form. So what we'll do is we'll take this negative 2y, move it to the right-hand side by adding it. So we're left with 6x minus 4 equals 2y. Then, to put it into y equals mx plus b form, all we have to do is divide both sides by 2. All right, and that gives me y equals 6x divided by 2, which is 3x, and then negative 4 divided by 2, which is negative 2. All right, so now we can see that both lines are the exact same. All right, so when you have two lines that are the exact same, they are just lying on top of each other, and they will have an infinite number of solutions. All right, so just to recap, that is this chart. And again, this chart is given to you under the modules. So number of solutions. To have one solution, the lines are going to intersect at one point. Right here, your slopes are different. That's how you can also tell that there'll be only one solution. When they have no solution, the lines are parallel and the slopes are going to be the exact same. So just like we saw up here, the slopes were the exact same, your y-intercepts will be different. And lastly was having an infinite number of solutions. The lines are coincident, meaning the two lines are lying on top of each other. The slopes are the exact same, the intercepts are the exact same, the two lines will be the exact same, and it'll look like just like one line, and there's an infinite number of solutions. All right, so this example, this is example number 2 in the modules. It's on page 622. So the question is, without graphing, analyze each system to determine whether the system is going to have one solution, no solution, or infinitely many solutions. So our two equations are given here. This form is already in y equals mx plus b form. So let's change our 3x plus 5y equals 15, and let's change it to compare the two lines. So I'm just going to do that over here. So I'm going to subtract the 3x over to this side. That leaves me with 5y equals negative 3x plus 15, and then divide by 5 on both sides. And we end up with y equals negative 3 over 5x, and then 15 divided by 5 is 3. All right, so our first line then is y equals negative 3 over 5x, and our second line is y equals negative 3 over 5x plus 3. So if we compare the two slopes are the exact same. So therefore, this system will have no solution because the lines are parallel. And since they're parallel, they will never cross. And will never I'll just put intersect. All right, so again, the two lines are parallel. They will never intersect, so therefore there is no solution to this system. Next, we have two lines again. First line is x minus 4y plus 8 equals 0. That's our first line. And our second line we're given is y equals 1 over 4x plus 2. All right, so this line is already in slope-intercept form, so we don't need to change anything to that line. This line, let's change it to slope-intercept form. All right, so what I'm going to do is add the 4y to both sides. So x plus 8 equals 4y. And then I'm going to divide by 4 on both sides. And that leaves me with y equals 1 over 4 x plus 8 divided by 4, which is 2. All right, so we're looking at two lines. This is our first line, and this is our second line. So if we look at these two lines, they are the exact same line. So basically, it's two lines lying on top of each other. So therefore, infinite number or infinitely many solutions. Infinitely many solutions. And it's because both lines are the exact same. All right, so our last one, we have two lines. Our first line is 7x plus y equals 12. Our second line is x minus 6y equals 5. All right, so we are going to have to change both of these lines so that we can compare them. So we'll put both of them into y equals mx plus b form, the slope-intercept form. So here for this line, all we have to do is subtract the 7x. So y equals negative 7x plus 12. So that's our first line. On this side, I'll bring my this negative 6y, I'll bring over to this side, and I'll bring the 5 eventually onto this side. So I end up with x. I'm going to bring the negative 5. I'm going to bring 5 over to this side, so I'll subtract the 5, and it equals to 6y. And then I just have to divide by 6 on both sides. So it looks like this. And it leaves me with y equals 1 over 6x minus 5 over 6. Minus 5 over 6. There we go. All right. So looking at our two lines, our slopes are totally different. There's nothing the same with these two lines. So therefore, they will intersect at one point. So there is one solution. Because the slopes are different. All right, so that is how you can determine whether lines will have one solution, no solution, or infinitely many solutions, is by putting them into the slope-intercept form, the y equals mx plus b form, compare the slopes. If the slopes are different, they'll have one solution. If the slopes are the exact same, the lines are parallel, they will never have a solution because they will never intersect. And if the slopes are equal and the intercepts are equal, it's the exact same line, and therefore there will be an infinite number of solutions.